So now this video discusses on how we can be able to determine the center of a mass of a systems in a one dimension as well as the two dimension. So what is the center of a mass? Let's say we have the object which is resting on the horizontal ground. Let's say this is a typical object of mass given as m, and let's say it is resting on the horizontal ground. Let's say that is the case. One of the forces acting on the object, it is a force due to the gravity, and which is always point downwards, and we call it as the gravitation force, which is expressed as the mass of the weight of the object, given as the mg. And there is one thing you should have to understand about the gravitation force. In all cases, gravitation force act at the center of a given object or the system. And for this case, given that this object it is a regular object, then the gravitation force will act exactly at the center of the active object, and which is given as mg. So one thing with the gravitation force is that it acts at the center of the object. And what is that center of the object? And that center of object is said to be the center of a mass. That is the point in which the mass of the whole system of the object is said to be concentrated on. That is what we call as the center of a mass. It is a point on a system or the object in which the whole mass of the system are said to be concentrated on. That's what we call as the center of a mass. For instance, if this is the object, the center of a mass, it is exactly at the center of the object where the gravitation force is acting on. So at the center of a mass, that's where the gravitation force acts on. And the gravitation force, whenever it is acting on the object, it seeks the center on its own. Even if you can have, object like this. This particular object has got the center, and in which the gravitation force can have to act. And that particular center gravitation force actually seeks that center on its own. So each and every object has its own actually a center of a mass where the gravitation force actually is said to act on. And even if we can have an object on the ground plane, let's say this is the object on the ground plane, let's say that is the case. So we understand that according to the principles behind the forces acting on the ground plane, according to the principles behind the forces acting on the ground plane object, one of the forces is due to the weight of the object, and which is pointing downwards like this. Despite that the object is being horizontally, despite that the object is being slanted, actually oriented, but a stromal gravitation force find its own center where it has to act. So this is the center of this given object. So that is the point in which the whole mass of the system are said to be concentrated on. That's what we call as the center of a mass. Now let's say we have the system of the masses in one dimension. Let's say we have this is the object of mass 1, and let's say we have the object of, let's say, mass 2, and I'll call it as m2. And let's say the two objects are connected by, let's say, a metal bar. It should be that, or can be they are connected by, I should say, let's say the objects are being pressed on a metal bar like that. And now if we consider that the object of mass 1 is on the position 1, or have it as x1, which means this is position 1 for object of mass 1. And if that is the case, then the object of mass 2 is on position 2. So now, since this is the starting position, then the object of mass 1 is on position 0. So that is the starting point. And let's say the object of mass 2 is on a position given as L, where L is the length of the metal bar. So in that way, so how can you be able to determine the center of a mass of this kind of a system? Now the center of a mass is as symbolized as Cm, that which is equal to mass times its position, and that plus mass 2 times its position 2, and that divide by the summation of the masses. So this is the formula that used to have the center of the mass. And if we have the system of, let's say, several masses, principle remains the same. We'll have, let's say, another mass with its respective position, and so forth, where you just have to add the masses and down there to have the center of the mass. So that's how you start to understand about the center of a mass of a system in one dimension. Let's say we have this kind of a case. We have, let's say, this is the object of mass 1 given as 2 kgs. And let's say we have another object, let's say, we should have it as the object of, let's say, mass 2, and which is about 10 kgs. Let's say that is the case. And let's say if this is the case, and let's say the distance from object of mass 1 to object of mass 2 is, let's say, given as 20 meters. So what is the center of a mass of a system? As it stands here, object of mass 1 being given as 10 kgs, and it is at a position x1 which is given as, so that is the origin. And the object of mass 2, it is at a position of x2 which is given as 20 meters. And now the center of a mass will not be given as 2 times what is the position, 0 plus, and we'll have should be at 10 times, and what is the position, 20 meters, and I divide by the summation of the masses, which is a 2 plus 10, and that should be that, so which is the same as, we'll have it as 200 meters, and I divide by what is the summation of the masses, we have it as 30. So from there we can be able to have the center of mass with that will be given as, now should be 20 divided by 3, that is given as 6.7. So the center of mass is given as 6.7 meters. So this is how you used to have the center of mass of a given system. And by the way, the masses should be, where am I getting 30 there? Now should be divided by 12. That should be the way out. So it's divided by 12. That corresponds to have it as, should be 200 divided by, should be 12. So we have it as 16.7 meters. And as you can see, this is really true because as you can see the system, object of mass 1 has, actually a mass 1 is less than mass 2. And if that is the case, for the system to be balanced, the center of mass has to be closer to the object of the more mass. So that's how you start to understand that one. And what if, let's say, we have this kind of a system, we have, let's say we have this kind of a system. Let's say we have this kind of a case. And let's say this is the object of mass 1, mass 2, let's say mass 3. Let's say this is 20 kgs, should be that, let's say 50 kgs, and let's say 2 kgs in that way. And let's say in this case, this is 5 meters, and let's say this is 3 meters. Let's say that is the case. So what is the center of a mass of a system? Principle remains the same. We have mass 1, which is given as, should be 20 kgs. And what is its position? We have it as 0, that is the origin. And we have mass 2, which is given as 50 kgs. And what is its position from the origin? We have it as 5 meters. Should be that. And we have mass 3, which is given as 2 kgs. And what is its position from the center? We can have it as 5 plus 3, which is given as 8 meters. And now what is the center of a mass? We'll have it as mass 1 times its position, mass 2 times its position, plus mass 3 times its position, divided by the summation of the masses. So try to have that. Now, you should have to understand that whenever we have the system of 2 masses, if I let's say mass 1 is greater than mass 2, it means the center of a mass will be closer to the object of more mass. And likewise, it should be, if that is the case, the center of a mass will be closer to object M2. And likewise, if if mass 2 is less than, let's say, mass 1, the center of a mass will be closer to actually a mass 1. Likewise, if the objects are of the same masses, the center of a mass will be exactly at the center. So take note of that. Now let's say this is kind of a question. 2 point masses should be 2 point masses of 2 kgs. We have mass 1, which is a 2 kg. And what is the position of mass 1? It is given as, should be the position of mass 1 is given as x1, which is equal to 2 meters. And we have the another mass, which is mass 2. We have it as 6 kgs. And let's say its position is given as 80 meters. So what is the center of the mass of the system? So I recommend that sometimes if there is a possibility of having a diagram, you should have to come up with a diagram. And as it gives a picture of you, actually, as it gives you a picture on how you should have that one. So 2 masses, so which means we should have to regard that, let's say this is the origin. We should have to regard that this is the origin, should be that. So now which means a mass 1 is at the position from the origin, it is at the position 2 meters. Let's say, let me use something here. Let's say it is at the position of, let's say, 2 meters. So that is mass 1. And the mass 2 is at the position of, let's say, should be 80 meters away from the actual origin. So which means it is about, let's say this is 6 meters. And that is mass 2. So we'd like to have the center of a mass of the whole system. So we understand that the center of a mass, which is a cm, now will be given as mass 1 times its position plus mass 2 times its position divided by the total masses. We'll have that and as that. And what is the, actually we'll have it as now the mass 1 being given as 2 kgs. And what is its position? 2 meters in the plus. Mass 2 will have it as, should be 6 in times its position given as 8. Should be 8. And that divided by what is the summation of the masses? We have 2 plus 6, that is 8. So have it in meters, that is. Then what is 2 times 2, which is given as 4? And the plus 6 times 8, that is given as, so 6 times 8, that is given as 48. We'll have it as 48 divided by 8, open meters. And that is 48 plus 4. So what would be that? And that divided by should be 8. That will be given as 6.5. So that is a 6.5. That is the center of the mass of the given system. So keep that in mind. And how about, let's say, if we have this kind of equation? Let's say this is the case. 3 masses. We have a mass 1, which is 1 kgs. And what is its position? That is x1. We have it as 0 meters. And we have mass 2, that is 3 kgs. And what is its position? We have it as -4 meters. And I have mass 3, that is given as 5 kgs. And what is its position? We have it as 10 meters. So what is the center of a mass of a system? So let's think of coming up with actually a diagram and to show the positions of these masses. Now for this case, let's regard this is a Cartesian plane, and which is the origin. And now for that case, actually a mass 1 is located at the center where x is cell. So that is actually a position of a mass 1. And how about the position of mass 2? That is -4. -4 corresponds to have it as to the negative values of x. So which means a mass actually 2 has to be somewhere here. That is a position of -4. That is a 4 from the origin. Mind you, we are having these distances from the origin. So it is since the position is -4, it means from the origin to the left along x-axis. That's where our object of mass 2 is located. That is a -4, of course, meters. And what is mass 2? It is about 10 meters to the right. That is, we have mass 3 here. That is about 10 meters. So the question is, what is the center of a mass of a system? You know, principle remains the same. Center of a mass should be the center of a mass. You know, has to be given as mass 1 times its position, mass 2 times its position, plus mass 3 times its position, divided by the summation of the masses. So try to have that and complete it. Let's say if we have this kind of a system. Let's say we have a Cartesian plane. Let's say let's say this is and let's say this is an object of mass 1, should be that. And let's say this is an object of mass 2, should be that. And let's say this is the object of mass 3. And let's say this is the object of mass 4, should be that. And let's say the mass 1 and the mass 2 are of about, let's say, 2 meters. And let's say from the origin we have something about 3 meters. And let's say here we should have something about 4 meters. And let's say this is about 4 meters as well. Let's say that is the case. And the mass 1 is given as 6 kgs. And the mass 2 is given as 2 kgs. And let's say mass 3 is given as 20 kgs. And let's say this is given as 60 kgs. So what do you think will be the center of a mass of the system? You know, the center of a mass of a system, principle remains the same. It is the system of 4 masses. Now the center of a mass will be given as mass 1 times its position, mass 2 times its position, and the plus mass 3 times its position, and the mass 4 times its position, and that divided by the summation of the masses, should be that. Now, what is the position of mass 1? So from the origin, mass 1 is on the position of -5. That's from the origin to where mass 1 is. You know, therefore x1 is given as -5. So x1 is given as -5. And what is the position of mass 2? From the origin, mass 2, its position is -3. And how about the position of mass 3? Actually, how about the position of mass 3? You know, its position has to be given as +4. And likewise, the mass 4 is about 8 meters from the origin. So from there you can be able to have the center of a mass of the given system. And now let's extend our discussions by looking at the center of a mass in 2 dimension. Now if you have the system in actually in 2 dimension, the center of a mass will also be given in two dimensions, whereby we'll have the center of a mass in x and versus the center of a mass in y. So this is how the center of a mass will be obtained if we have the system in two dimensions. And if that is the case, the center of a mass in x will be given as the mass 1 times its position along x. Let's say mass 2 times its position along x. Likewise, if we have another mass, it should be that divided by the summation of the masses. And likewise, the center of a mass along y will have it as mass 1 times its position along y and plus mass 2 times its position along y and divided by the summation of the masses. So that's how you start to understand the principles behind the center of a mass in a two dimension. And let's say we have the two dimension coordinate system. Let's say this is the case. And let's say we have this is the object of mass 1, and let's say this is the object of mass, let's say mass 2, and let's say this is the object of mass, let's say 3, and let's say this is the object of mass, let's say 4. And now let's say the mass 1 is given as 2 kgs, and the mass 2 is given as 20 kgs, and the mass 3, let's say, is given as 10 kgs, and let's say this is given as 30 kgs. Let's say that is the case. And let's say a mass 2 is of 5 meters away from the center, should be the origin. And the mass 1 is given as, let's say, 6 meters. And let's say this is the 3 meters, and let's say this is 4 meters. Let's say that is the case. So how should you have the center of a mass of a system? Now this is a two-dimension system. So in this case, we should have to understand that the center of a mass, if we have the system in two dimensions, has to be given as the center of mass along x, comma, the center of mass along y. Now what is the center of mass along x as well as the y? So first thing, we should have to look at the positions of each mass in x as well as y. Let's just start with the mass 1. What is the mass 1? We have it as 2 kgs. And what is its position along x is given as a mass 1 is found along y-axis. It has no position along x-axis. And what is its position along y? We have it as, in other words, it has no position along x-axis. So what is its position along x-axis? It should y-axis. We have it as 6 meters. And on mass 2, we have it as it should be 20 kgs. And what is its position along x? We have it as 5 meters. And what is its position along, should be now, that should be given as x2, y2. And that is to show that we are dealing with mass 2. And what is its position along y? We have it as since the object is in x-axis. And let's go for mass 3. What is mass 3? We have it as 30, should be 10 kgs. The mass 3 is given as 10 kgs, should be that. And what is its position along x? We have it as -3 meters, and since it is to the left of the origin, it should be x3. And what is its position along y? We have it as 0. And we have mass 4. What is mass 4? We have it as 30 kgs. And what is its position along x? We have it as 0. And its position along y, we have it as, should be y4 given as, should be -4 meters. So should be that. So now how should you have the center of a mass if that is the case? So we'll have the center of a mass along x. And then now we'll have it as the center of a mass along x will be given as, no, should be given as mass 1 times its position along x plus mass 2 times its position along x plus mass 3 times its position along x, and likewise mass 4 and its position along x. So should be that. Let me just have to substitute the values. So what is the mass 1? We have it as 2. And what is its position on X? We have it as L. And the plus, let me just have to have it as L, by the way. So since it's L, we'll have it as L. So have it as L plus. What is the mass 2? And we have it as, should be 20. And what is its position along X? We have it as a 5. So have it as 100. And the plus, what is mass 3? We have it as, it should be 10 times, what is its position on X? We have it as negative 3. So 10 times negative 3, that will be given as negative 30. So have it as negative 30. And how about the mass 4? We have it as 30. And that should be 30. And what is its position on X? We have it as 0. Therefore, have it as 0 plus. What is mass 4? It should be mass 3 rather. Should be mass 4. We have it as, it should be that. So we have 1, 2, 3, 4. We're enough there. And I divide by the overall summation of the masses, which is 2 plus 20, that is 22. That is 22. And the plus 30, that is 52. And that is 62. Half 62. And what is the center of a mass along Y? So that is, now we have it as 100 minus 30, that is 70. And 70, divide by 62. That is now being given as 1.1 meters. So that is the center of a mass along X. And how about the center of a mass along Y? Try to have that one in the same way we have done it here. And upon having the center of a mass along Y, then you have to conclude that the center of a mass is given as so, and comma so like that. So let's also appreciate this kind of a system of the objects. Let's say we have this case. Let's say this is a kind of a question, and the question says a 2 kg mass, that is a mass 1, given as 2 kg, is at the position 2,3. So if that is the case, you should have to understand that these are the coordinates on a 2-dimensional coordinate system. Therefore, x1 is given as 2, and the y1 is given as 3. And we have mass 2, which is given as 4 kgs. And what are its positions? X2 is given as 6, and x should be y2. That has to be y2 is given as, should be 7. So we should have the center of a mass of the system. So try to have that. And also let's consider this kind of equations. 3 masses, we have mass 1, mass 2, mass 3, and these are their respective positions. And on the mass 1, this is it's actually x1, y1, x2, y2, x3, y3. And on the second case, this is we have 2 masses. And now for this case, this is x1, y1, x2, y2. And for this case, we have actually 2 masses, that is x1, y1, x2, y2, like that, and so forth. So try to interpret in the same way, of the way it is there for the rest of the other questions. So that's how you start to understand about what you create as the center of a mass of a system in a 2-dimension. Sometimes you can also have this kind of a system. Let's say we have a 2-dimensional coordinate system as well, and let's say this is an object of mass 1, and let's say we have an object of mass 2, and let's say we have an object of mass 3. Let's say that is the case, and let's say from the center and that should be, let's say from the center, by the way, you should have let's say from the center we have, let's say, a distance given as r, which is given as 6 meters, and let's say on the other object, and from the center, let's say the distance is given as, and let's say the object 2 is of, let's say, 10 meters from the center, and let's say the object 3 is at some distance, whereas r given as, let's say, 8 meters. Let's say this is the case, and that is at an angle theta, let's say, given as 59 degrees. Let's say this is given as 29 degrees, and let's say this is given as, should be that of, let's say, 47 degrees. And let's say mass 1 is of, let's say, 7 kgs. The mass 2 is of, let's say, 20 kgs, and the mass 3 is of, let's say, 30 kgs. So how should we have the center of a mass of this kind of a system if this is the case? So in this case, we need to have the coordinate positions of these actual masses, in the sense that we should have to resolve the distances from the center into components. So where we should have something about, where we should have to resolve the distances into components, that we should have the components. So we use the same principle of the vector resolution. So have that on. Now we have to resolve into components, and that is we should have that. So make sure you understand about the vector resolution. So upon having resolved the vector, actually the distance into components, then that's when you'll be able to determine what is x. For this case, the x component of let's say the x component of the distance, or now corresponds to given as x1. The y component will be given as y1. Likewise, you have x2, and the y2, you have x3 and y3. So try to have that on. Now let's say we have this kind of equation. A 4 kg mass is located. We have a mass 1 which is 4 kgs. Is located in the distance from the origin is given as 10 meters, and at an angle of 30 degrees above the positive x-axis, and that is the angle theta, which is given as 30 degrees. And we have another mass, whereas mass 2, which is 6 kgs, and it is at a distance of, there should be 8 meters at an angle of theta, which is given as 120 degrees. Should be that. So we should have the center of a mass of a system. You know, principle remains the same. This is a 2-dimension, system, where we should have to present, let's present the system, object of mass 1 at an angle of 30 degrees above the horizon. So this is angle of 30 degrees above the horizon, and basically this is the object, that is mass 1, and the distance from the center is given as r, which is given as 10 meters. So we should have to resolve this into components in order to have, x1, and also in order to have y1. And we have another object that is about 120 degrees, so we have to measure it from the positive x-axis up to that point, so which means this is a typical 120 degrees we can have. So that is 120 degrees, of course, and that the object happens to be here. Let's say this is the object of mass 2. It should be that, and the distance from the center is given as 8 meters. Of course, I've just drawn a very longest line, but anyway, much as you know the concept of the vector resolution, no, nothing will matter here. So that is the object of mass 2, and that is the distance of should be 8 meters from this, actually from the origin. So of course, instead of using the angle of 120 degrees, you can think of using this angle. What is this angle? This is the angle of 60 degrees. So you have to resolve the actually 80 meters into components, where you have where you have should be x2 and also y2. So try to crack that one. And also let's apply the same principles in these questions here. So try to apply the same principles, whereby we have 3 particles are located at, so we have a particle of mass 1, which is at should be of a mass 1, which is 80 meters, should be 80 meters at an angle of should be 30 degrees. And we have mass 1, which is 4 kgs, about 10 meters at an angle of 120. We have another one 6 kgs, about 6 meters at an angle of 240. We should have the system's center of mass. Let me just have to present the coordinate system. And where are these actually objects or the masses located or found? Let's study the object of mass 1 about 30 degrees. So that is the first quadrant. We have it as, this is the object of mass 1, 30 degrees. Should be that in the distance from the origin, it's 8 meters. We should have to resolve that one. In the object 2, 120 degrees, so which means we're talking about this. That is in the second quadrant. So that is the object of mass 2. And the distance is given as 10 meters. And the object 3, it's about 240 degrees. So which means from the origin, we are to go like this. Let me have to present this one as this. You know, from the origin, we are to go like this. This is where 240 has to be located. That is at 240. And this is the object of mass 3. And the distance from the origin, that is 6 meters, we should have to resolve. And of course, if you wish, you can resolve using this angle. So you can resolve that one, should be using this angle. That will be given as 270 minus 240. That is 30 degrees. So you can use this angle to resolve 30 degrees. So keep that in mind. So for you to defeat these kind of equations, you need to review much about the concept of the vectors and basically vector resolution. So this is how you start to understand about the center of a mass of the systems in a 2 dimension as well as in a 1 dimension. Thank you.